clear blue skies. It's been great conditions for looking at the comet. I don't know if any of you have gotten out there to see it. I forgot all about it last night. We were watching a show called 6 Feet Under. We just kind of got into that and forgot about the comet. 6 Feet Under, that's kind of a soap opera for the new generation, the way I like to think of it. Clear skies in Texas, and even from geostationary orbit we can see, it's so clear we can see the roads and some of the cities. Here's Dallas right here, and Fort Worth located right out here. And yeah, from 22,000 feet away, or 22,000 miles away, we can see Highway 75 and 121 and even Interstate 20 there. Yeah, pretty impressive. Let's zoom out and see what's happening around the rest of the country. I think this time of year it's pretty important to start with radar. I haven't been doing enough of that, but we need to see what happened overnight, because that's going to have a huge influence on the boundaries we end up with later in the day. So I'm going to run this back to yesterday during the afternoon. Looks like a lot of shower activity across New Mexico and Colorado. And as we roll forward into the sunset hours, we see an MCS coming together in the Texas Panhandle up into Baca County, Colorado. And that moves eastward through the Oklahoma Panhandle, adjoining sections of Texas into the after midnight hours, and then across Oklahoma in the pre-dawn hours. And there it goes. And what you have to think of is that this is laying down a boundary. Okay, so it starts dissipating there around noon, but we can assume that outflow boundary is going to be left somewhere in here. Now we can look at the Oklahoma Mesonet to find it. Here's the current chart. What do we see here? Let's go down to the south where there was likely no MCS. See there in southeast Oklahoma? Run that back. Yeah, you can see that MCS do not affect southeast Oklahoma at all. So that's going to be relatively unchanged air. So we move north until we start finding evidence of a boundary. It looks like we picked that up near Interstate 40. That dividing line is going to be right in there. So you see that there? Cooler air, northeasterly flow, and we'll just trace that back. Gets a little more indistinct in southwest Oklahoma, where we have the very strong heating, but we do see the divergent flow there in western Oklahoma. So yeah, there's definitely a cold pool through that region. So if I had to guess, I'd say that boundaries like that, then on the northern end, it's going to be up there somewhere. It's probably off the map, but anyway, let's head to the satellite. And there we see the remains of the MCS in southeast Kansas. Run that back to around dawn. And you can see it was a little bit more extensive, and it's very interesting transverse banding there on the edges. That can be a pretty potent area for clear air turbulence. Going back further, looks like a lot of debris in the Four Corners area. There could be a little bit of upper level lift. It's kind of got that S shape, so it makes me wonder that could be just coincidental. And rolling that forward, yeah, there is quite a bit of lift across the Four Corners area. Have to check the upper level charts for a trough. Well, I'm not really seeing any evidence of anything in that area, so I think that's probably coincidental. There could be a little bit of flattening right there. Maybe it could be a trough right in there. We're really kind of grabbing at straws there, but I don't know. I would probably be inclined to think that that's coincidental. 500 millibar winds are kind of weak in that area, but if you draw a streamline, you get this kind of flattening of the wind field. So I think, yeah, there could be something very weak in there. But anyway, there's the surface chart for early this afternoon. Looks pretty quiet, very typical weather there in the southwestern U.S. Looks like a thermal low through the southwest deserts, and the dry line is kind of receding into eastern New Mexico. That's what we typically see this time of year as the moisture works further and further back. In fact, you could make a case that the dry line is even further back here, and I think that may be exactly what's happening. In Oklahoma, there's that old frontal system, and superimposed on that is that outflow boundary. So that's going to be the location. Might need to adjust that a little bit from the Oklahoma Mesonet analysis. And then down to the south, not much going on. Upper 80s and lower 90s, and moisture. Looks like the moisture axis kind of running about like that right there. In the northwestern U.S., mild, and it looks like picture postcard weather. Is that the phrase, postcard picture perfect? I don't know. It does look like the marine layer is coming onshore in Washington there. Some low 60s coming into the Seattle area, but out in the high deserts, 80s, and it's very common for this time of year. Satellite also showing clear skies just about everywhere. I mean, this would be a great time of year to be out in Yellowstone or anywhere out west. And let's run the satellite loop, just see if we're missing anything. Yeah, some convective debris through the Great Basin area into the Rockies. And it looks like the cold air advection in the high plains has subsided. In the northeast, you may remember that baroclinic system that was back in Illinois and heading for Michigan. Well, now it's about to clear Michigan, and it's coming into Ontario, Lake Erie, and Ohio. So that right there is probably a region where we're going to see convection later today. I can see some unstable-looking clouds there in Ohio, and possibly some towers in the Cleveland area. So that'll be something to watch. But you go a little bit further south, and we do pick up the tropical air mass. So I would say we probably have a warm front somewhere in this area right here. And out back behind that region of towering cumulus, we see much flatter clouds with not much vertical development. And that's probably convection back behind the frontal boundary. So a lot of these clouds here are stratocumulus, and they're topping out at the frontal transition layer. And then we go further back and we get more into the dry air, and this becomes high-based cumulus, fair weather cumulus, and transitions over to clear skies. The surface map showing the polar front, basically just east of Detroit there, coming into the Sarnia, Ontario area, and the cold front extending down through Columbus to Cincinnati. And looks to me like the warm front is probably out in Pennsylvania. Maybe I could draw that a little bit further west. I would think maybe, based on the data, something like that, because you can see the air is much warmer to the south, and it transitions to mid-70s in New York and eastern Pennsylvania. And you notice also the cloud shading, marginal VFR conditions right there. That aligns very nicely with the location of the warm front, which is either there or a little bit further west. That matches up. And for the southeastern U.S., a good place to start, again, is the radar. You might have heard of continuity. That's a good starting concept for your forecast if you're not expecting any major weather changes, which is often the case in the southeastern U.S. this time of year. So let's run this back to yesterday afternoon. Remember, we had that MCS in southern Alabama. That basically spread northward, and some of it reached Atlanta and Macon around dusk there. And looks like maybe, I think that might be an eastern outflow area around Tallahassee. And then around midnight, everything died out. And that's where we're at. Looks like, some unsettled weather off of the New Orleans coast. Might be fed there by the land breeze or maybe some upper level support. Usually at nighttime when you're seeing stuff like this, I would start looking at the upper levels. And then running that forward through the morning hours, pretty quiet. Nothing going up yet except just some air mass stuff in the Carolinas. And the stuff up to the north, that looks like it's along that cold front. So now we have a pretty good picture of what's happening. Let's look at the satellite. And there's our satellite loop. Looks like a kind of disorganized cluster south of New Orleans. And things look pretty quiet throughout the rest of the southeastern U.S., but it is still early in the convective day. This area here in northern Alabama, that looks like maybe some subsidence affecting that area. There's also a good chance that could be overturned air from convection yesterday and last night. So do we have an upper level system? Let's take a quick look at the GFS. And yeah, we do see this area here of higher vorticity. That would be kind of an easterly shortwave, like that, moving towards the west. Because, you are south of this subtropical ridge, so the flow is going to be moving that way. Let's run that forward and just kind of see what's going to happen for today. Looks like whatever that is shifts into Louisiana. So that may be where we see a lot of the convection today. And then going into Friday, looks like it shifts into the Houston area. So I might expect maybe to look for an increased chance of precipitation on the Texas coast. Then for Saturday, that little shortwave moves into the Rio Grande region. So maybe some rain. San Antonio, Laredo, Corpus Christi. We'll see. They've been in a drought, but maybe this will break it. And there's the surface map for this afternoon there. The Bermuda High kind of extending a little bit into the Georgia and southern Alabama area, so that may dry things out a bit. And then, of course, we got that weak cold front lurking up to the north. There may be some convergence along that. So a quick look at our storm scenario in the northeast U.S. Warm front is about like that. Cold front down here. This is the nose of the moist sector. It's not just low pressure. That's where highest theta E air is. So we're going to see this region here come together with deep convection this afternoon. So running that forward, you can see these storms coming together from west of Erie to west of Pittsburgh. And of course, that's the Allegheny Plateau area. We learned about that yesterday. Another line looks like it's coming together around State College up to Buffalo. Probably a pretty uncapped air mass, and little MCS coming together in far western New York. Looks like around evening, lots of thunderstorm activity in western New York and probably kind of disorganized. And then with the loss of heating, they dissipate. The Capes, take a quick look at that there. I guess we'll go with the most unstable Cape. I don't really like using that too much because it tends to overestimate Cape, but I don't think it hurts to look at a worst case scenario. Possibly up to 2,500 there. Let's check out what the mixed layer Cape is, which is going to be better. And that puts us more in the 1,000 to 1,500 range. And then a quick proximity sounding around Akron. Looks like we got plenty of moisture all the way up to about 2 kilometers. Very uncapped air mass. It does look like one problem is poor lapse rates. See the lapse rates up here in the mid-levels, they're conditionally unstable. Almost an inversion up there at about 300 millibars. So that'll probably take away from the Cape just a little bit, probably put us more in this 1,700 range. But still, good moisture there. The wind profile does show a slightly sheared environment. The problem is you got these southwesterly 30 to 40 knot winds with southwesterly at 30 to 40 knots aloft. So that's going to cut down a little bit on your bulk shears. You can see that on the photograph there. Some good 0 through 1 kilometer elongation. That's definitely good. The rest of it is a problem, though. So not much storm separation. That means you're going to get a lot of cell interactions, probably a lot of clusters going up, but where they go severe, where there's good access to moisture, probably some of them will be rotating. And you can see the STP is up above 1. So it looks like the likelihood of a non-tornadic situation is kind of low. It's up in that top whisker right there that you see in the bottom right. And it puts us pretty squarely in the EF0 to EF1 range. So somewhere there will probably be a weak tornado. It's hard to say where with the boundaries being not very well focused today. Okay. We'll put on our spooky music here and do our astronomy calendar. Over the next week, we'll have Comet Neowise in the evening above and to the right of the setting sun. Now, I don't think that comet has a whole lot of brightness. It's probably going to be hard to see unless you've got a view very low to the horizon, at least 15 to 20 minutes after sunset. But you never know, so check that out. Also, July 23rd is going to be where the comet is closest, but I would imagine as it moves away from the solar wind, that by itself will cause it to diminish a little bit. So it's hard to say when the best viewing conditions are going to be. And then in August, the Perseid meteor shower. We'll be talking about that in a couple weeks. The Blue Ridge Mountains. Where are they? Well, the Blue Ridge Mountains are part of the Appalachians, and we find this in western North Carolina into western Virginia. I think you could probably see a little bit better. Well, on the regular map, it looks like that. That's where the Blue Ridge Mountains are, but let's check out the terrain map. And there we can see it much better. Now, yesterday we talked about the Allegheny Plateau right in there, also the Cumberland Mountains back in here, the Cumberland Plateau. But the Blue Ridge Mountains are these mountains right here. And there's a subset of that called the Great Smoky Mountains, located right in there. That's going to be along the Tennessee-North Carolina border. Now, these are definitely important, especially in the wintertime. These actually block a lot of the cold air from moving west or southwest, and we end up with something called cold air damming. When that flow comes around to the south, that air mass has nowhere to go, and it kind of sits here. Meanwhile, we have cold air or warm air spreading northward from the Gulf, from the southern states, and we end up with a front kind of in this region right here. And it actually curves back up into the Ohio River basin, kind of like that. So that's called cold air damming, and the old ADA model from the 1990s, that was developed to cope with this very situation. So the models have gotten quite a bit better since those days. So anyway, there's the Blue Ridge Mountains and the Great Smoky Mountains. Two good mountain ranges to memorize. And that'll do it for a Thursday edition of Meteorology Lab. Thank you all for joining and watching, and those of you who are supporting the program, it's very much appreciated. Have a great evening, and we will talk to you tomorrow. Bye-bye.